So far in this series, we have looked very closely at the retrograde movement of Venus and the pentagram of Venus. But you would be surprised, I'm going to tell you now, that these are not the most important characteristics of the orbit of Venus. The most important characteristic of the orbital dynamics of Venus is what I'm going to show you in this video, and that's known as the elongation of Venus. And I'm saying this is the most important because the entire Hindu mathematics of Hindu astronomers to decide the accurate position of Venus in the sky is based on this idea of elongation. So let me start by once again showing you. So this is the heliocentric model. Sun is at the center and Venus and Earth are going around the sun. And you have seen the movement of this. But I am now going to add the line of sight of the sun. The moment I add this line of sight, immediately you get an angle between the two. And this angle is nothing but elongation, which is shown as epsilon here. And the value of this elongation right now, epsilon, is east 36.5 degrees. Now, this concept of elongation is very familiar to you. We have discussed this when in the Argana series long back, elongation of the moon. And that is the central astronomical parameter for defining a tithi. Every 12 degrees increase in elongation is a new tithi, 12 degrees, 24 degrees, 36 degrees, etc., etc. We have seen that already. Now, the same idea of elongation I am bringing to Venus. How far is Venus from the sun? As observed from the Earth in angles, in degrees. So, on day 0, which is 8th June 2026, Venus is east of the sun and it's 36.5 degrees away from the sun. And why do I say this is east? Because here I have put the compass. All the planets are orbiting west to east. Now, you know the diurnal movement, the daily movement is east to west, sunrise, sunset, etc. But the sidereal movement, the orbital periods of sun, moon, and all the planets is in the opposite direction, west to east. And this is harder to observe, but ancient Hindu astronomers observed this 1600 years back. So right now, Venus is east 36.5 degrees, elongation. Elongation is by definition distance from the sun. Good. Now, I'm going to run this simulation and you see what happens to this elongation. It starts increasing. It's become 42 degrees, 43 degrees, 45 degrees. And now let me go day by day. It's 46 degrees and this is the maximum it reaches, 46.0405. 0545, 46.0545. This is the maximum it reaches. After this, it starts reducing. 0513, and it starts going down. Now, as the elongation goes down, Venus is approaching the inferior conjunction. Elongation is going down, and what's going to happen? Retrograde movement starts. And when retrograde movement starts, you see Venus is approaching the sun. The elongation is just 5 degrees now. 3 degrees, 2 degrees, 0.5 degrees, and now what's going to happen? It's going to cross over to the other side, west, 1.0689 degrees. So during retrograde movement, it sweeps across to the other side of the sun, to the west of the sun. Now prograde movement has resumed, but it's still increasing to again 46 degrees it will go and then starts reducing again. Now gradually as Shukra is approaching superior conjunction, this elongation will keep reducing. Takes a longer time now. Now it's 25 degrees. And as Shukra comes to superior conjunction, the elongation becomes 0 and crosses over to the east of the sun there. Now it's east. So the basic pattern which emerges here is that Shukra, though it is orbiting the sun exactly like the earth is orbiting the sun, west to east, when we stand on the earth and observe it, it seems to be going east and west of the sun with a maximum elongation of 45, 46 degrees on either side. So again, it's approaching 46 degrees. And you know what's going to happen now. A second retrograde movement is going to start. There, it's crossed 46 degrees. Elongation is now reducing, and it's going to now sweep retrograde movement. Zoop, it sweeps back to the other side. And now prograde movement started. This pattern goes on and on and on and on eternally. As we observe from the earth, it looks like Shukra is going east of the sun, west of the sun, east of the sun, west of the sun, perpetually, like a pendulum, where this is the center of the pendulum, and this is the swinging pendulum which goes in an arc. But during retrograde movement, it goes really fast. Otherwise, it goes aramse and crosses. Now it's going to cross over again from west to east. West to east is very aramse, slowly, like this. But east to west will be a very rapid sweep backwards. So this pattern keeps repeating again and again. And I'm saying that this pattern forms the crux of the mathematics that was used by ancient Hindu astronomers to determine the position of Venus. I'm going to explain that in future videos. The concept is amazingly fantastic. But right now, you understand it moves east, west, etc. But I also have to introduce another very popular concept actually, which is directly connected to this. The concept of Venus being a morning star and an evening star. So for that, let me reset the date back to 0 and I bring on the zodiac. So now in addition to the elongation, I'm showing you that Venus is an evening star on day 0. It is east of the sun and it's an evening star. What does this mean? See, the basic idea is, so this is the sequence of the Rashi Mandala, Mesha, Vrishabha, Mithuna, Karkata, Simha, etc. So in the morning, they will rise in this sequence. Mesha will rise first, Vrishabha will rise next, Mithuna will rise next, etc. etc. So when Venus rises in the morning, sun is already up in the sky. It's bright daylight, so you can't see Venus in the morning. Because once the sun is up, nothing is visible. And before the sun is up, Venus would not have risen. First, sun will rise, Vrishabha will rise, and only after that, Mithuna, Karkata will rise. But in the evening, they set in the same sequence. Mesha sets first, Vrishabha sets next, Mithuna sets after that, Karkata sets after that. So, first sun will set, sky becomes dark. Venus will become visible. And after that, Venus will also set. So, between sunset and Venus set, there will be some time, maybe half an hour, maybe 1 hour, maybe 2 hours, maybe 3 hours, when Venus will be visible in the western sky. And it will be visible not more than 46 degrees from the horizon. It won't go over your head. Venus will never appear directly above your head. It will be always in the western sky in the evening as an evening star, about 45 degrees or less, closer to the horizon. So I will illustrate that to you by switching over to stellarium. Because to talk about rising and setting, I need to show you a horizon, right? So I can't just show you that GeoGebra model doesn't have a horizon. So here I'm in Bangalore in stellarium. This is my day 0, June 8th, 2026, 4:30 in the evening. And sun is about to set in the western horizon. Okay. And sun is in Vrishabha, about 23 degrees. Now Venus is somewhere here, Mithuna Karkata border. But you can't see it because there is sunlight. It's daytime, it's evening, but its daylight is there. So let me run the simulation. And as the sun sets, When the sky becomes dark, Venus will suddenly become visible here in this part. So let's wait for the sunset. So it's 5:30. Now it's approaching 6 o'clock. Sun is still somewhere there, I think. Yeah. Now it's dawn clearly and the sky is becoming dark. Watch this space. There. Venus became visible. In the evening, at 6:50, as late as 6:50, Venus finally became visible. That's why it's known as the evening star. Elongation is about 33.95 degrees, which is close to what I showed you there in GeoGebra. There I showed you about 36 degrees. It's 33 degrees here because sun has gone a couple of degrees below the horizon before Venus actually becomes visible. Its sky is dark enough. From here onwards, Venus will continue to be visible, nice and bright, kind of low on the horizon, until Venus also sets. Same thing applies to Buddha also. That's also an interior planet. Guru is different. That I will explain sometime eventually in the future. So this is why Venus is known as the evening star. And now Venus is also going to set, after which, of course, it will not be visible. So there is a window in the evening when Venus will be visible in the west. This is the basic idea of evening star. Now, what about the idea of morning star? Let me come back to GeoGebra and start the simulation again. Let's wait for it to sweep from east to west. You know that it's going to happen in the retrograde movement. Now the elongation is maximum. It's going to reduce now. And anytime now retrograde movement starts and it sweeps back, crosses over to the other side and goes to the west. Now let me kind of wait until it goes to 200 days. There. So elongation 45.3 degrees west of the sun, and I call it now the morning star. Same logic, because early in the morning, long before sunrise, Tula will rise. Like 3 o'clock, 4 o'clock, Brahma Muhurta time, Venus will rise first, and eventually after that, sun will rise, Dhanu will rise. So before sunrise, like 3 a.m., 4 a.m., etc., Venus will be visible in the eastern horizon. Not more than 45 degrees above the horizon. It will rise up to 45 degrees, then sun also will come up and Venus will disappear. Evening, Venus will set first during daylight hours. After that only sun will set. So evening you cannot see Venus at all. So this is a morning star. So let me demonstrate to you morning star also using stellarium. So here we are. This is the 200th day. Day 200 is December 25th, the day of Christmas. Early morning, 3 o'clock, I am showing you the simulation in Bangalore, eastern horizon. And first Tula is going to rise. This is where Shukra is. And there is Shukra. So now Venus is visible early in the morning, well before sunrise. You need to wake up really early to see the morning star. Not just before sunrise, but really well before sunrise. So 4:30 and until sunrise, it will be visible in the eastern horizon. Now it's 5 o'clock. 5:30, nicely visible, no problem at all. Now it's dawn. And as the sun comes up, you will see Venus slowly fading away. And it's almost gone. By about 6:40, Venus has practically disappeared. And its elongation came up to 45 degrees, 45.17 degrees now. Similar, comparable to what I showed you in my GeoGebra simulation. Stellarium is more accurate than my GeoGebra simulation. And after this, of course, Venus simply will not be visible because it's sunrise, and once the sun rises, you can't see anything else. Everything else is gone. So this is why Venus is called morning star sometimes, and that will happen in after November 15th, it will become a morning star. Immediately after November 15th, it will barely rise and disappear quickly. By December, by Christmas time, it will nicely rise from 3 o'clock up to about 6:30, and you'll be able to see it in the morning in the eastern horizon. So now I come back to my GeoGebra. So these are the ideas of morning and evening stars. Now this morning and evening star is not explicitly mentioned in Surya Siddhanta, but they go one step better. There is a chapter in Surya Siddhanta where they discuss the formulas for how do you determine the heliacal rising of Venus, rising and setting of Venus. What that means is, what is the first date on which Venus will become the morning star or the evening star? From that day onward, Venus will be morning star. From that day onwards, Venus will be visible as evening star. That first day, that's called heliacal rising. It's not ordinary rising, it's more complex. This morning, evening star, very first time it becomes visible. That much they were able to calculate and say, on this day onwards, it will be visible as morning star. After that, for so many days, you can see as a morning star. Or from this day onwards, it will be visible as evening star. After that, for so many days, you can see it as an evening star. That calculations they were able to do 1600 years back. So think about it. If you feel that what I explained to you now in this video is complex, just keep in mind that all this was well understood, not maybe in this form, the heliocentric form. I will show you in the next video as to how they understood it. But the basic concepts were understood and mathematically implemented 1600 years back by Hindu astronomers who composed the Surya Siddhanta.